Hello and welcome back. This video covers the Unit 7B test review. We'll start with number 13 and go to the end, and then go back and pick up the beginning questions. So starting with number 13, it says to state the domain of each function in interval notation. And then it says you do not need a graphing calculator to answer these. So as stated, you should be able to do this without looking at a graph. Let's start with number 13. All right, the function is f of x equals x divided by x minus 5. Let's look at the numerator. What is the domain of just the numerator? Well, we could use all real numbers for x in the numerator. There are no restrictions, so that's negative infinity to infinity. Well, what about the denominator? Well, in the denominator of a fraction, we know that the denominator cannot be 0. Therefore, x cannot be 5. So now, putting both of these together, in the numerator, we could use any number from negative infinity to infinity, but in the denominator, we cannot use 5. So then our final domain will be all real numbers except for 5. And the way you write that is negative infinity to 5, union 5 to infinity. All right, for number 14, the numerator is x minus 2. And what is the domain for that? Well, we can use any number in the numerator, so that's going to be from negative infinity to infinity. Well, to figure out the restrictions of the denominator, we'll first factor that. And that will factor into x minus 1 times x minus 1. And we know that the denominator cannot be 0, which means that x cannot equal 1. So, putting all of this together, our domain for the entire function is all real numbers from negative infinity to infinity except for 1. So we write that as negative infinity to 1, union 1 to infinity. Okay, for number 15, we have the square root of 9 minus x squared, and that's divided by x minus 4. So with a square root function, we know that the inside of the square root cannot be negative. So whatever we plug in for x, we have to make sure that it stays positive or 0. Now, the most I could plug in for x would be 3, because 3 squared is 9, and 9 minus 9 is 0. If I plug in anything greater than 3, that would cause the inside of the square root to be negative. Likewise, I could plug in negative 3 for x, and that would give me 0 inside. But if I tried to plug in negative 4 for x, that would make the inside be negative. So I could plug in negative 3, I can plug in positive 3, and I can plug in any number between negative 3 and 3. So in the numerator, my domain is negative 3 to 3. Now in the denominator, I know that the denominator cannot be 0, so that means that x cannot equal 4. So what is my domain for the entire function? Well, it's going to be from negative 3 to positive 3, because 4 is not inside that interval. So my final answer is that the domain is simply negative 3 to 3. And that is with brackets, because x can be negative 3 and it can be positive 3. So we're including negative 3 and 3. All right, for number 16, we have x on the top, and then we have square root of x minus 1 on the bottom. Well, the x on the top, there's no restrictions at all there, so we could use negative infinity to infinity for the top. However, for the bottom, there's two things happening here. First of all, we cannot let the denominator be 0, so that means x cannot equal 1. But also, it's a radical, and so that means that x has to be positive, so that means x has to be from 1 to infinity. So putting that together, so x has to be from 1 to infinity, but also x cannot equal 1 because it can't be 0. All right, so then putting this all together, it would have to be that x would have to be between 1 and infinity. And that 1 is without a bracket. because 1 cannot be included. All right, so the domain is 1 to infinity. All right, number 17. In the numerator, we have a radical, and we know that the radical can't be negative, so that means that we would have to start at -7 and go to infinity for the domain in the numerator, from -7 to infinity. Now, in the denominator, we have x squared minus 4, and the restriction there is that the denominator cannot equal 0. So what values of x would cause the denominator to be 0? That would be -2 and +2. So x cannot equal -2, and x cannot equal +2. So what is our domain? It's from -7 to infinity, but we have to remove both -2 and +2 from that. So the way you would write it is from -7 to -2, union -2 to 2, union 2 to infinity. And for number 18, we have a radical on the top, and we know that the radical can't be negative inside. So the most that we could plug in for x would be 5. If we plug in anything more than 5, we would get a negative inside. So for the numerator, x could be anything less than or equal to 5, and we would write that as -infinity to 5. Now in the denominator, we know that it can't be 0. So what makes the denominator 0? Well, that would be -2. Therefore, x cannot equal -2. So what is our overall domain? Well, it's going to be -infinity to 5, except for -2. So how do we write that? That would be from -infinity to -2, union -2 to 5. All right, for question 19, we have a function. We're going to be graphing this. We're also going to be talking about the transformation. Let's discuss the transformation first. So we have the absolute value function, and in front of that we have a 1/2. So we know that the 1/2 vertically shrinks the graph. So it's a vertical shrink by a factor of 1/2. And then inside the absolute value we have x minus 8. We know that moves the graph to the right 8 units. And then the +2 on the outside moves the graph up. So it moves to the right 8 plus up 2. Now let's get into a table. We know that for the absolute value function, we use the numbers from -2 to +2. And the fact that this has been moved to the right 8 units means that we should be adding +8 to each one of these original x values. So -2 plus 8 would be 6, -1 plus 8 is 7, 0 plus 8 is 8, 1 plus 8 is 9, and 2 plus 8 is 10. Now we simply plug in each one of these x values into the original function. So if you plug in 6 minus 8 is -2. The absolute value makes it +2. You'll multiply that by 1/2, and that'll be 1. And then plus 2 makes 3. Then if you just plug in the rest of these numbers, 7, you get 2.5. If you plug in 8, you'll get 2. If you plug in 9, you'll get 2.5 for y. And if you plug in 10, you'll get 3 for y. Now, what does that look like on the graph? These are the 5 points, and you just draw the V shape through those points. Now, what is the domain and the range? Well, the domain goes to the left and right forever, so that's -infinity to infinity. And what is the range? Well, the range begins at y equals 2 and goes up towards infinity. So the range is 2 to infinity. And here's number 20. We have an absolute value function again. Now there is a 2 in front of the absolute value, so that 2 is going to cause a vertical stretch. So it's a vertical stretch by a factor of 2. Now the 2 is negative. What that does is reflects it over the x-axis. Now inside we have the x plus 3. That's going to move it to the left 3. And then the minus 1 is going to move it down. So it moves to the left 3 and then down 1. All right, let's look at our table. Again, for absolute value, we usually go from -2 to +2. Now, since this has been shifted to the left 3, we're going to be subtracting 3 from all of these x values. That results in the following table. So -2 minus 3 is -5. -1 minus 3 is -4. 0 minus 3 is -3, and so on. Now we're just going to plug in all of these numbers from -5 to -1. We'll plug those in for x, and we get these corresponding y values. We simply plot this on the grid, and this is what the graph looks like. Now, what is the domain and the range? Well, the x values go to the left and to the right forever, so your domain is going to be -infinity to infinity. But the range goes from -infinity and then it cuts off at -1. So range is -infinity to -1. And number 21, we have a square root function that has been transformed. All right, first let's talk about the transformation. The +3 causes a vertical stretch by a factor of 3. And then the x minus 2 moves it to the right 2 units, and the +4 moves it up 2 units. So to the right 2 and then up 4. All right, let's do a table for square roots. The original square root function would start with 0 and then 1 and then 4. Now because this has been moved to the right 2 units, we're going to be adding 2 to each one of these x values. 0 plus 2 is 2, 1 plus 2 is 3, and 4 plus 2 is 6. Now let's plug in 2, 3, and 6 into the equation for x, and you'll end up getting these corresponding y values, 4, 7, and 10. What does the graph look like? Well, 2, 4 is here, 3, 7 is here, and 6, 10 is here. So it begins at 2, 4, and then goes through these points upward. All right, finally, what is the domain and the range? Well, the domain starts at x equals 2 and goes towards infinity. And then what is the range? The range starts at 4 on the y-axis and goes up towards infinity. So our domain is 2 to infinity and the range is 4 to infinity. All right, and for graph number 22, looks like we have a cubed root function. All right, let's talk about the transformation. We have a 1/2 in front. So when you multiply by half, you vertically shrink the graph by a half. Now there's also a negative there, and that negative reflects it over the x-axis. We have the x minus 1 inside, and we also have the -3 outside. The x minus 1 is going to move it to the right 1, and then the -3 moves it down 3. All right, now let's begin looking at the table. When you're talking about cube root functions, the basic graph begins with -8 and goes to +8. Those are our original numbers, from -8 to +8. Now, because the graph has been shifted to the right 1 unit, we're simply going to add 1 to each one of these original x values. And if you add 1 to each one of those, you end up with -7, 0, 1, 2, and 9. After plugging these x values into the equation, we get the corresponding y values of -2, -2.5, etc. to -4. All right, now we'll just plot those points on the grid, and this is the graph that we get. All right, finally, let's talk about the domain and the range. The domain goes to the left and to the right forever, so that is negative infinity to infinity. And also, the y values will also continue to increase. They do not level out as it might appear. They continue to increase slowly, going up towards infinity and also going down towards negative infinity. So both the domain and the range are negative infinity to infinity. All right, now we're going back to the beginning and we're solving these equations from 1 through 12. Starting with number 1, we see that we have an absolute value equation. So the first thing we do is drop the absolute value bars and set 5 to be positive or negative. We'll then move the 3 over by subtraction. And so we get negative x equals plus or minus 5 minus 3. And then we have to get rid of the negative, so we'll divide everything by negative 1. And we get plus or minus 5 and then plus 3 there. Well, if you do negative 5 plus 3, you're going to get negative 2. And if you do positive 5 plus 3, you get positive 8. And so we have two answers. That's negative 2 and positive 8. And if we were to plug both numbers back in for x to check it, both numbers would work. Okay, for number 2, we have an absolute value is equal to 9. So let's drop the absolute value bars and set it equal to plus or minus 9. Let's go ahead and add 3 to both sides. So we'll have 4x equals plus or minus 9 plus 3. And now let's go ahead and divide by 4 on both sides. So x is plus or minus 9 plus 3, all divided by 4. Now that's going to give us two answers. If we do negative 9 plus 3, that's going to give us negative 6 over 4, which reduces to negative 2/3. That's one answer. And then positive 9 plus 3 is 12, all divided by 4 is going to give us positive 3 as our second answer. And both numbers work when you plug them back into the equation. Question number 3. We have an absolute value and then plus 2 equals 10. First, we'll need to move the positive 2 to the other side by subtracting. So that's 10 take away 2 is 8. And now let's drop the absolute value bars. So 3x plus 4 is equal to plus or minus 8. Now let's subtract 4 from both sides. So we have 3x is plus or minus 8 minus 4. And now let's divide by 3 on both sides. And we get plus or minus 8 minus 4, all divided by 3. Now if we do negative 8 minus 4 and then divide by 3, we'll get negative 12 over 3, which would be negative 4. And then also, if we do positive 8 minus 4, that's 4 divided by 3 is going to be the fraction 4/3. So we have two answers, 4/3 and negative 4. Both answers do work, so they are both valid. All right, for number 4, we have the absolute value here. So we want to get the absolute value by itself on one side. So first we'll move the minus 7 over by adding it. So adding 7 to both sides, we get 2 times the absolute value equals negative 2. Then we'll need to divide by 2 on both sides. So now we have the absolute value is equal to negative 1. And at that point we can stop, because the absolute value cannot equal a negative number. And therefore, this is no solution. Okay, for number 5, we have the cube root of this expression minus 2 times the cube root of 6 is equal to 0. We want to isolate this cube root on one side, So we're going to add the 2 radical 6 to the other side. So that gives us the cube root of 3x plus 21 equals 2 times the cube root of 6. Now we want to get rid of the radical, so we're going to raise both sides to the power of 3. That gets rid of the radical on the left, so you just have 3x plus 21. On the right side, you are raising 2 to the third power to get 8, and then the cube root of 6 raised to the third power, that just removes the radical, and so you have 8 times 6. Well, 8 times 6 is 48. Now let's subtract 21 from both sides. We now have 3x equals 27. Now let's divide by 3 on both sides. And we get x is equal to 9. And when you plug in 9 back into the equation for x, you will see that it does equal 0 on both sides. So x is 9. And here is number 6. So we have 2 times the radical plus 18 equals 6. We're going to try to get the radical by itself, so let's go ahead and subtract 18 from both sides. So we have 2 times the radical equals negative 12. Now let's divide by 2 on both sides, and we get the radical equals negative 6. And at that point, we can stop, because we have a fourth root, and the fourth root of a number is not negative. It can't be negative. This is very similar to a square root. Okay, fourth root cannot be negative. So we stop and simply say that there is no solution. All right, and here's number 7. So we have 3 times x minus 5 raised to the 3 over 2 minus 6 equals 642. Well, we want to try to get this exponent by itself. So let's go ahead and add 6 to both sides first. And we have 648 on the right. Now let's divide by 3 on both sides, and that gives us 216 on the right. Now we need to undo this exponent, so we'll raise both sides to the reciprocal power. And the reciprocal of 3 over 2 is 2 over 3. So the exponent goes away on the left, leaving us with x minus 5, and on the right it's 216 to the 2/3 power. Now we should be able to do this mentally, but you can also use a calculator. But the cube root of 216 is 6, and then 6 to the second power is 36. So that's why we have 36 over here on the right. Once again, cube root of 216 is 6, and then 6 squared is 36. All right, now all we have to do is add 5 to both sides, and we're going to get x is equal to 41. Now if you plug 41 in, you're going to get 642 on both sides. Just a quick example of that is, so 41 minus 5 is 36. You're going to take the square root of that. That'll be 6. And 6 to the third power is 216. And then 216 times 3, that's going to be 648, and then subtract 6 leaves you with 642. So plugging in 41 does work. All right, for number 8, we want to get this parentheses with the exponent by itself. So let's add 5 to both sides, and that results in 54 on the right. Now let's divide by 2 on both sides, and that results in a 27 on the right. Now we want to undo this exponent, so we'll raise both sides to the power of 5/3. That's the reciprocal power. So that results in 4x cubed minus 13 equals 27 to the 5/3. Well, then to evaluate this without a calculator, that means we're taking the cube root of 27, that's 3, and then you're raising that to the 5th power, and that's going to be 243. So we have 243 on the right. Now let's add 13 to both sides, giving us 256 on the right. Now let's divide by 4 on both sides, and that gives us 64 on the right. And now we have x to the third equals 64, so we'll just need to take the cubed root of 64. And the cube root of 64 is 4. And if you plug in 4 into the original equation for x, it will work. And for question 9, again, we want to get this parentheses with the exponent by itself, so we're adding 10 to both sides, and the result would be 16 on the right. Now we'll undo the exponent by raising both sides to the reciprocal power, so that's to the 3 halves. So that would be 5x plus 14 equals 16 to the 3 halves. Now 16 to the 3 halves means to take the square root of 16, that's 4, and raise that to the third power, and that's going to be 64. Subtracting 14 from both sides leaves us with 50 on the right, and then dividing by 5 gives us our solution, x equals 10. And if we plug in 10 for x in the original equation, we would find the equation to be true, so it works. All right, number 10. We want to get the parentheses with the exponent by itself, so we're adding 7 first to both sides. We get 16 on the right. Now let's get rid of the 2 by dividing, and 16 divided by 2 is going to be 8 on the right. And now we'll just raise both sides to the reciprocal power. So that's 4x minus 12 equals 8 raised to the 5/3. That means we're going to take the cube root of 8 and then raise that to the 5th power. So the cube root of 8 is 2, and then 2 to the 5th is 32. So 32 is on the right. Now let's add 12 to both sides. So we get 4x equals 44, and then divide by 4, and we get x is equal to 11. And when you plug in 11, it does work, so that is our solution. All right, for number 11, we want to get one of these radicals by itself on one side. So let's go ahead and add this radical to both sides. So now we have radical on the left equals radical on the right. Now we'll raise both sides to the 3rd power to get rid of the radical. That results in 4x minus 1 equals 2x plus 7. Now we'll just need to get all the x's on one side. So if we subtract 2x from both sides, we get 2x minus 1 equals 7. And then adding 1 to both sides, we get 2x equals 8. And then dividing by 2, we get x equals 4. And it's true that if you plug in 4 for both of these x's, it would give you 0. So x equals 4 is our solution. And here's number 12. We want to raise both sides to the 2nd power to get rid of the radical here. That's a square root. So raising both sides to the 2nd power, we have x plus 5 equals x plus 3 squared. Now x plus 3 squared needs to be expanded, so we'll just FOIL that out. That's x plus 3 times x plus 3, and that's going to be x squared plus 6x plus 9. Now we'll need to set one side equal to 0 because we recognize this as a quadratic equation. So let's move the x plus 5 over to the right side by subtracting. The result is 0 equals x squared plus 5x plus 4. And then we recognize that this can be factored. That'll be factored into x plus 4 times x plus 1. And then our potential solutions would be -4 and -1. But we have to be careful. If we plug in -1, let's see what happens. So plugging in -1 for both x's, -1 plus 5 is 4. and the square root of 4 is 2. So we have 2 on the left. And negative 1 plus 3 is also 2 on the right. So negative 1 does work. If we plug in negative 4 for x, both x's, negative 4 plus 5 is 1, and the square root of 1 is 1. That's positive 1. But if we plug in negative 4 on the right, that's negative 4 plus 3 is going to be negative 1. So on the left we have positive 1, but on the right it's negative 1, and that is not a true statement. Therefore, we end up having to cross out negative 4 as a solution, so only one solution is valid, and that is x equals negative 1. All right, that concludes our review for Unit 7B. Our test is coming up. Please study and prepare well.